All right, 3, 2, 1.
Well, hello everyone. This is the LIDAR robot demo. To start off, over here, if you can see, we have a screen plotting what the LIDAR robot sees. And basically how this works, if you take a closer look at the robot over here, you have a spinning wheel. One stationary, that spinning wheel has two holes. One hole will shoot out a laser, and the other hole is the camera that's tracking the laser. So the way this works for a given range, since it's a very dim laser, it will shoot at a surface, but if the surface is not reflective enough, it won't plot. So that's why you do have limited range capabilities, and this definitely works best under an enclosed maze environment, where you can clearly outline walls, which you kind of can. I mean, in this case, it's just showing tables. If you look in the bottom left corner, you probably see me moving around, and just blobs of points, as I like to call it. That is the gist of how this works. Currently, we're working with an Xbox controller for motion controls. It can be inconsistent, but for the most part, it just needs kind of a warm-up. I think just to dive a little bit in how the code mechanics work, for the joystick itself, or for the controller itself, what we have is mainly just axis motion. So, to better explain, you have your trigger buttons like your RC, LT, or even just your bumpers. But we found that with Pygame, axis motion is a lot more consistent. So in this case, I have the left joystick just for turning, as you can see. And then the right joystick, weirdly enough, maybe not as intuitive, is for going back and forth, whenever it does choose to do so. Inconsistent motion is definitely a thing, and there's lots to look at, I'd say. But it's definitely at a better and more intuitive point. I would say this controller is just better to use and easier to learn and understand. You also have more options. You could just end up defining different axes for different motions.
And the controller is new this year.
Yeah, the controller is new. We used to have just a 2-axis system. Now, in theory, this is a 4-axis system because each joystick is 2 axes, right? So if, for instance, they only have 4 motions, you could just choose each axis for each independent motion. Like let's say only want to use the horizontal axis of each joystick for turning, and then use both verticals for forward and back. You could do that, and it'd probably be a lot more hassle-free. But that is the gist of how the code works. Besides that, I will definitely add documentation on how to run the code and the most common errors you might run into. If for some reason I'm not here next year and somebody else has to run this after they've uncovered it in one of the cabinets. But yeah, I mean, this is the LIDAR robot. Definitely a lot of fun. Definitely a lot to learn from. But yeah, just feel free to be creative whenever you look at this. It might seem daunting, 400 lines of code, but just kind of give a shortcut. You can really just skip down to the joystick loop, which is about line 250 or so. And from there, you can have your fun, play around with whatever you like. Yeah. I think the beauty of this demo is just seeing what LIDAR can do. Everyone has a robot that moves at some point, but LIDAR itself, and just being able to outline the things around you like that, is definitely a more unique feature than most demos we have. So yeah, thank you.
No, thank you. Good job.